Hello, everyone. Welcome to our broadcast of our webinar on biosolids impacts and measurement. Just popped my face up here at the beginning. My name is Patrick Hill, one of the founders here at Triple Point. I've been working on lagoon systems for the better part of 17 years, pretty much, well, my whole professional career. I presented lots of these webinars if you've seen them before, also at conferences, including WEFTEC and lots of rural water conferences, and worked on literally hundreds of lagoons. So I hope to share some of my experience and some of my knowledge with you today, and you get something out of it. This module is part of our masterclass series, which we launched, I think, a year and a half ago or so, and we're kind of working through the sort of 6 key track areas of lagoon process, biosolids, algae, nutrients, data analysis, and troubleshooting. So obviously this fits into the lagoon biosolids portion of it, and we hope that once we get this masterclass done, you can watch the whole thing from start to finish and be a lagoon master. All of these webinars are on a Lagoon University system, which you can get to via this URL below. You can also get to it via our website. We've recorded basically all of our webinars over the last, I think we've been doing maybe 8 years or 10 years, and put them on here, and you can watch them. In some cases where we're able to get CEU credit for operators, we get them, and you can watch them and get credit for those. For engineers, there's definitely PDH credits that are available, but it's completely free, on demand. You can really learn a lot from these webinars. So I really encourage you to go check out our Lagoon University platform. It's actually fairly popular. So we have this class this week on measurement and impacts and measurement of biosolids. Next week, we're going to talk about remediation and removal. That'll be me, same time next week. Then the week after, my colleague Brady is going to talk about lagoon hydraulics. So this is our sort of series here for the first half of the year, and if you can make those other two, that'd be great. I think there's some really good education there, and again, we're just continuing this masterclass thing. So if you've got the link, great. If you need the link, please put a request in the chat. We'll give you a link, and you can sign up for the next ones too. So let's get started here. We're going to talk about biosolids, impact and measurement. And you may be wondering why I've got this warrior here pictured here. Well, this is Achilles, and in Greek mythology, Achilles was the greatest of all the warriors. And it was thought that he was immortal because his mother, when he was a baby, dipped him into the river Styx and held him under the water and held him by his heel. And so it was thought that his whole body could not be killed except his weakest point was his heel, and hence the phrase, the Achilles heel, because that was what was not dipped into the river Styx. And so I think of lagoon biosolids as kind of the Achilles heel of lagoon systems. This is the thing that can kind of get overlooked, and every wastewater plant in the world has to manage biosolids in some way. And lagoons do this by storing them in their lagoon for 20 years. And so as just a matter of design, every lagoon has sludge, and people complain about it, but it's really a feature, it's not a bug. And at some point, you need to remove those solids. You need to manage those biosolids. Lagoons, unfortunately, are not immune to the need to manage biosolids. You just don't have to do it very often. I often hear things where people say things like, lagoons don't work, or our lagoon stopped working. And most often, the reason that happens is because they have too many biosolids, and they have not managed their biosolids, or they can't remember the last time that they removed biosolids. They have no idea how many they've got. And so to sort of complain about lagoons that way, for me, is like, it's like driving your car, never changing your brake pads, and then saying, well, the car doesn't work because I got in an accident because I couldn't stop. It's like, no, the car works just fine. You just gotta change your brake pads every once in a while. right? And so this is, I think, such a critical topic. So what I want to talk about today are what are the lagoon biosolids, some of the biology, the problems that excess biosolids can cause, and you'll see these symptoms. And if you see these symptoms, it's usually a sign you gotta remove your biosolids. Why you should measure them, how to measure them, how to calculate sludge volume, and so on. And so I hope this becomes useful for you because this is a really critical part of lagoon management in my mind. Probably one of like 2 or 3 things that are super, super critical about managing lagoons to make sure you can do it effectively. So what are the biosolids? Well, there's really 2 components to your biosolids. This here is a pile of lagoon biosolids that was removed from a lagoon in Iowa that we worked on. You have the volatile component, or sometimes it's called the organic component of your biosolids. And this could be undigested BOD. This could be complex organics. So those are things that just are harder to break down, right? So plastics, paper, leaves that flow in, that come from trees, or whatever that's just a little bit more dense and complex. Rags, like the rags that come in your collection system, that would be considered a complex organic. And so like the bacteria in the lagoon are pretty lazy, right? They're going to eat the food that's easiest to eat. And usually the BOD that's freely available in the water column, they're going to eat that first. But then, they eventually get around to eating these complex organics, including plastics, which is really crazy. It just can take time, right? It just takes a lot longer for them to eat it, a lot longer for them to break those things down. Other things include dead biomass. So that's a big portion of this as well. So that can be like dead bacteria. The microbial community grows, eats the food, eventually it dies. Some of that microbe can be broken down pretty easily and cannibalized by other microbes, but some of it's harder to break down. It takes longer to break down. Think of it like if you had an animal die in the woods, right? It's going to break down over time, but the last thing it's going to break down is the bones, right? Because that's the more dense, complex structure. So that's really where the dead bacteria are. And then you also have dead algae and dead duckweed, and those make up your volatile components. Your non-volatile components are inert, right? So these are the sand, grit. Sometimes if you have ductile iron pipe, you'll flake some of that ductile iron pipe off over time. Just anything that really just is not going to be broken down. Heavy metals, things like that. And obviously those are not things we can do much about, and those things are eventually going to need to be removed from the lagoon, regardless of how much digestion we get in the lagoon itself. And there are actually, with the mechanical plants, there are whole systems that are designed just for grit removal, and that's the type of stuff that we're trying to remove. That's in the non-volatile component of lagoon sludge. So sludge biology. So you have to think of your sludge blanket as kind of a separate habitat within your lagoon. Typically, you have your sort of more aerobic zone above where the sludge blanket is, or anoxic zone above where the sludge blanket is, and that's where your DOs are, anything from 0 DO up to, let's say, 1 or 2 or maybe even 10 DO, depending on how much dissolved oxygen you have in your lagoon. Your sludge blanket typically is anaerobic, which means you don't have any oxygen in there, or very little oxygen in your sludge blanket. There are sort of like 2 main species of bacteria living in your sludge blanket that are important to note here. You have, on the one hand, your acid-forming bacteria, and this is like kind of the first half of a partnership of the 2. These bacteria, they break down molecules into organic acids such as acetic and butyric acid, and so they tend to drive down your pH. Your sludge blanket tends to have a lower pH than the rest of your lagoon does. The second sort of group are the methogens on the one hand, and as you might gather from the name, and you get a clue from the name as to what these guys do, is they're taking that acid and they're converting it to methane. And so that's their job. And then you have the sulfate reducing bacteria, and they're the ones who create those nice, smelly sulfur dioxide smells that you get. from lagoons sometimes, especially if you have too much biosolids, and we'll talk about that a little bit more. But they basically they substitute the oxygen in their metabolism for the methane, and they create sulfur dioxide. And so on the one hand, these bacteria are really good at reducing sludge. They're like an anaerobic digester on the bottom of your lagoon, right? So they'll actually break down sludge over time very slowly, but they'll do it, which is awesome. But they're bad because, they get this odor and sometimes some septicity if you have a lot of sludge within your lagoon itself. So what are the problems when you have too much biosolids? So I'm going to talk about each one of these, what the mechanism that drives this problem is and exactly how it affects you. But, you get low DO, high BOD due to reduced treatment, turnover that can happen in the lagoon, which can manifest itself in floating sludge, as you can see from this picture here, which is lovely, by the way, if you've ever been on a lagoon with floating sludge on it. Benthol feedback, pH issues, and algae overgrowth. So biosolids, if you have too much biosolids, they can cause all of these things. Now, that's not to say biosolids cause these things by default. They don't. Properly managed biosolids will cause these things to a degree, but not to a degree where you're going to be super concerned about it. When you have too much biosolids is really where you start to have really acute issues around this. So the first thing to talk about is benthol feedback. And the reason I put this one first is because literally the word benthol is, it means coming from the bottom. So in reality, all of these issues are coming from the biosolids, the sludge, and they're all benthol issues to some degree or another. But they occur because of the anaerobic digestion process that's sitting on the bottom, and they can be exacerbated by lagoon turnover in the spring and potentially the fall as well, but mainly the spring. So what are the issues with benthol feedback? Well, you get benthol feedback in particular can re-release ammonia, phosphorus, and also put more BOD in the water column, put some of that undigested BOD portion of your sludge back in the water column for you, which is not always great. It fuels algal blooms, driving up TSS. We'll talk a bit more about that later. It drives down your DO, it lessens your aerobic activity, which lessens your BOD treatment. It increases your anaerobic activity, which creates odors, and it can lead to floating sludge. So lots of issues associated with benthol feedback that all come from having too excess biosolids. One particular example that I'd like to share here is to look at the feedback of nutrients, in particular in this case, the feedback of ammonia. So this is a facility, it's a 3-cell lagoon system. The big cell on the left is your aerated lagoon. The second cell is your second aerated lagoon. The third cell is your polishing lagoon. And so this is some data here that we collected, or the operator collected mainly, testing kind of what is going into the polishing lagoon from an ammonia standpoint, what is coming out of the polishing lagoon from an ammonia standpoint, and what do those things look like. And as you can see from the graph, that this data is, it's kind of perplexing in a way. You actually have more ammonia coming out of the polishing cell than what was going into the polishing cell. So you start to ask yourself the question, what is going on here? Usually, as we move closer and closer to the discharge point in a system, in a lagoon system, in any wastewater system, you would expect to see all of your waste load constituents go down, trend downwards as you get closer to the effluent point. Well, what is happening here is, if you look at this pond, you can see that there is duckweed on it. And as I talked about, that is part of the volatile portion of the sludge, is dead duckweed. So what happens is the duckweed grows in the summertime, creates this beautiful natural cover, right? Dies in the wintertime, sinks to the bottom, and breaks down anaerobically in the summertime when it's 60-degree water temperature, when the dissolved oxygen is less than 2 milligrams per liter, and when you have a good enough sludge blanket where you got enough of this duckweed in there. And as it's breaking down the proteins in the duckweed, that duckweed is releasing, that dead duckweed in the anaerobic digestion process is actually releasing ammonia into the water column. So this is the type of thing that can happen that really can affect your ability to meet treatment limits. Well, as you know, ammonia is a form of nitrogen. There's also phosphorus that can come from benthol feedback as well. And so what do we use nitrogen and phosphorus for? Well, we use it as a fertilizer, believe it or not. There are plenty of lagoon systems that have been dredged where those biosolids are spread onto farm fields. And maybe it happens less so now than it used to, but back in the day, farmers used to fight over lagoon sludge, right? Because they wanted that really great nutrient material that had built up in that sludge blanket. So if you get some of those nutrients that can really be helpful in growing plants, they can also be helpful in growing algae. So I see this constantly where we have a lagoon system that has a really acute algae problem. And we ask them, hey, have you measured your sludge? Do you know how much sludge you've got? Right? 9 times out of 10, they have too much sludge, and that is fueling algae growth. Not only because of the nutrients, but because it also makes the lagoon shallower. And because it makes it shallower, it makes it easier for for algae to form. So this is a big, big issue. And in a lot of lagoon, and some would say most lagoon effluent violations can be caused by algae in the summertime. So one study here that I cite from Richard and Bowman looked at 24 Colorado municipal treatment lagoons and found that 2/3 of the effluent violations were due to algae overgrowth. They weren't due to a lack of treatment of the BOD and the ammonia coming into the lagoon from the collection system. They were due to the algae growing and that showing up as BOD and TSS at the back end of the system. And so, you go talk to some of these suppliers of such as Aquafix, who will help you with algae problems, and they're going to give you something that will help mitigate the algae now, but they're also going to give you stuff that's going to break down the sludge, because they know, like we know, that the sludge is being fueled by the fertilizer that is in that algae. That is in the sludge. The algae is being fueled by the sludge. So as I discussed previously, within your sludge blanket, you've got those acid-forming bacteria. Those acid-forming bacteria are doing what they do and creating butyric and other organic acids, and that's actually lowering your pH. And so the problem with that is that, if you're trying to maintain a microbial community, they typically perform best at more of a neutral pH. They don't want it too acidic. They do not want it too alkali either. And so when you have a lot of sludge and that sludge is then, say turnover, you get lagoon turnover, or some of that pH starts to lower the pH in the lagoon, which can not help with your basically your breakdown of BOD and also ammonia as well within the lagoon as well. So pH becomes a factor and becomes a concern at the point in which you have too much sludge, and that's really fueling lots of anaerobic sludge growth that creates organic acids. So sludge will also decrease your level of dissolved oxygen in the lagoon. So why? Well, I think you have to think of sludge as kind of your lagoon's memory of what's come into it over the last 10, 20 years, depending on how old your lagoon is. And that sludge, in a lot of cases, it has its own oxygen demand. It is breaking down anaerobically mostly, but it will take oxygen out of the water column. So when we look at dissolved oxygen within a lagoon, really what dissolved oxygen is it is residual oxygen that's there that the microbial community has not consumed over and above what they need to break down the incoming load. So that's why you get dissolved oxygen, essentially an excess of oxygen that the bugs don't need, right? But the problem with, let's say, designing an aeration system in a lagoon that has existing sludge is that what the loading coming in is. We can test the flow, we can test the BOD concentration, we can come up with a pounds per day of BOD coming in. But what we can't as easily do is design an aeration system for the unknown BOD that's sitting in the bottom of the sludge blanket. Not at least if you don't measure it, right? And so that also constitutes an oxygen demand. So as that sludge blanket builds up and builds up and builds up, you have all this undigested biochemical oxygen demand, right? That will consume oxygen within the water column itself. And so it can be a problem. It can be a problem in maintaining sufficient DO. And in some cases, lagoons do have dissolved oxygen limits at the effluent. And so if you have low dissolved oxygen at your effluent, it can be because you have too much sludge, because that is a BOD loading. Everything on the bottom of that lagoon can break down with oxygen if it has oxygen, and it will steal the oxygen out of the water column that it can, because the bugs will want that oxygen before they start to work in an anaerobic mode. I mean, in addition to oxygen needed, right, within your lagoon in order to promote the aerobic activity to break down the BOD, TSS, and ammonia, another big factor is what we call hydraulic retention time. So this is a measurement of the amount of time the average gallon of water, once it comes into your lagoon, how long it stays in your lagoon before it leaves. And this is a really, really critical design factor for us and for any lagoon, right? And as the sludge starts to accumulate and as it builds up, it starts to displace the volume. So it starts to reduce your hydraulic retention time over time, right? So if hydraulic retention time is lagoon volume divided by gallons per day flow, higher sludge equals lower volume, and lower volume equals lower treatment time, which equals higher BOD on the effluent. So it's like asking, your lagoon that started off on day 1 with 30 days of retention, and let's say 30 years later, it's got 50% full of sludge, right, which would be huge, and now it only has 15 days to treat that wastewater. It ain't gonna treat it as well, okay? That's not a mystery to anyone, right? You've just reduced the amount of treatment time that you have. So it's a big issue, and it's one that kind of creeps up over time as you build up sludge. So turnover, and this is sort of an apropos topic because we're sitting here in the spring, and I've seen this, I've had a number of calls about this already this year. So, often lagoons are referred to as ponds, and they look like ponds in a way. They're actually a wastewater treatment facility that kind of looks like a pond, but they do behave like ponds in a lot of cases, especially if you have a facultative lagoon, i.e. no aeration in it, or let's say you have a partial mix aerated lagoon, i.e. it's not completely mixed, it's only partially mixed, which is, say, between those two, the vast majority of lagoon systems. What you get is this phenomenon in the summer and the winter where you have different layers of water that have different temperatures. And so in the summertime, your top layer is your warmest, and we've all seen this if we've jumped into a lake, and the first 2-3 feet are the warmest, and you dive down, it gets really cold really fast. That's what we call thermal stratification. In the wintertime, it's kind of the opposite. Your top layer is your coldest, and if you're in a winter environment, you typically see ice formation at the top, and your bottom layer is the warmest. So one of the big things I see is really spring turnover. And so this is where the ice melts and all the layers of the water from top to bottom mix, the temperature equalizes, and you get all sorts of problems that occur. So let's just play the scenario out. So lagoon freezes, ice acts as an insulator at the top, the bottom of the lagoon is really warm. You still have anaerobic digestion occurring at the bottom of your lagoon, even in wintertime. It's maybe a little bit slower, it's a little bit colder, but it's still happening. And so that anaerobic digestion, as we know, is producing hydrogen sulfide and methane. Some of that hydrogen sulfide and methane is getting trapped by the ice. Some of it is just getting trapped underneath sludge particles. Just getting caught in these sludge particles, not really having enough buoyancy to lift them up quite at that moment. Spring comes along, ice melts, guess what happens? Well, all the trapped methane, H2S, that immediately gets escapes. So this is very common, right? You get that call and it's like the ice just came off and the lagoon stinks, right? Well, that's because that initial slug of methane from the anaerobic digestion at the bottom of the pond gets released all at one time when that ice melts. But you also, as the layers of the water mix, and this is kind of like the kicker, I think, for lagoons that have lots of sludge, is that you get kind of this boost in anaerobic activity because the lagoon in general starts to warm up. That boosts anaerobic activity, just like it boosts all microbial activity. And eventually you get more anaerobic digestion. Some of these sludge particles that float to the surface because H2S and methane build up underneath them. So sometimes you'll see popping sludge or floating sludge. Some of that gas will just get released right there and then. And then more importantly, a lot of that sludge will come up and it will actually, little bubbles, little methane hydrogen sulfide bubbles will literally lift the little BOD sludge particles into the water column, which will then depress the amount of oxygen, which will then increase the amount of anaerobic digestion in the lagoon because you depress the oxygen, because you put all this BOD that was sitting on the bottom into the water column. The aeration system, if you've got one, can't handle all that BOD at once. It was never designed for that. It was only designed for the incoming load, and you just get an odor problem, right? And it's neighbors calling, 50 complaints, it's all the above, right? And so this is what happens, and it tends to happen when you've got too much sludge. And that's when turnover can be a real issue, and it's a massive indication. I've had 2 different systems call me this year about this exact same problem. And in both cases, they have over 2 feet of sludge with it sitting on the bottom, which generally speaking is a little bit too much for most lagoon systems. So this is kind of the acute event, and if you recognize any of those things, that is what's happening, and it's not fun. So why should you measure your sludge? Well, I think the first and foremost, it's a very vital planning tool. You don't want to be in the position where you are having a fire drill come spring because you had a turnover event that is really acute due to all the sludge you have in your lagoon. So if you understand how much sludge you've got in the lagoon, and you can kind of see how quickly that sludge is building up year to year, then you can kind of plan ahead. You can project forward. You can say in 5 years we need to remove sludge. We're going to be at that 2-foot mark, right? Where that's going to be a little bit too much sludge, or it's going to be creeping on a little bit too much sludge, right? So it's really critical that you plan in order to avoid the issues associated with sludge. The second thing is, if you get that data, right, now you can budget properly for that sludge removal, right? Now you can understand what's the volume, what are the cubic feet of sludge that I have, right? And I mean, I've seen systems go out to bid, without any sludge information for contractors. They say, remove sludge, and the contractor's like, well, how much sludge you got? I don't know. Well, what kind of bid do you think you're gonna get, right? They're gonna have to assume you got a lot, because at the end of the day, they don't know, right? And you're not gonna do it cost effectively. So super important. And then when you do that contract, right, and you do have the contractor come out and remove that sludge, you need to know what was in there before, and then you need to go and measure what was there after to make sure that you actually remove sludge. Because I can't tell you the amount of times that I have heard from a customer, hey, yeah, we removed sludge 2 years ago. We do a sludge survey, they still got 2 feet, right? And we'll talk a little bit more about that next week as to how that occurs, why that happens, and how frustrating that is. But you need to know. And then if you know, you can hold them accountable to removing X amount of cubic feet, and it's pretty simple and not too hard to do. So you're gonna measure sludge. What are the key things? So there's 3 key things that I recommend. First of all, you gotta measure multiple points. This is a survey, right? This is not a sample, this is a survey. And so you can see here on the right here, a picture of our grid set up at a facility we did a sludge survey at. We had 36 measuring points in Lagoon 1, 45 in 2, 54 in 3. So we're taking a lot of measurements here, and we're making sure that we're getting a really good sense of how much sludge is in this lagoon based on all these different sampling points. Sludge does not does not equally distribute itself across the lagoon for your convenience. It really doesn't. It accumulates in certain spots and not in other spots, and it's kind of all over the map. Second thing, track across time. Make a habit of doing this. I think you can buy the equipment to do a sludge survey for probably $100 or $200 max. And you should do it every year, compare year to year, understand how much sludge is building up in your lagoon, understand how quickly it's building up in your lagoon. Really try to be proactive about this. This is a really important part of of lagoon management. You don't have to manage biosolids very often, okay? If you have to spend one day a year, okay, managing your biosolids by measuring the sludge, that's not too much to ask at all. I mean, go talk to the operators who operate mechanical plants and talk to them about how much time they spend managing their biosolids. Every day, they're thinking about their biosolids. Maybe every week at the very least, right? Depending on the type of plant. So don't take for granted that you've got these biosolids. You do need to manage them. Third thing is, when you do this survey, take core samples of the sludge. Okay, it's not good enough just to know how much sludge you have in your lagoon. You need to know what percentage of that sludge is the volatile organic ICAN breakdown component, and how much of that sludge is your inorganic component, right? The inert, the stuff we can't break down, right? The non-volatiles. And the other thing you would want to know if you go to a dredging situation where you're going to go dredge is they're going to want to know what heavy metals you got in there, what's in that sludge, so that they can understand how they can dispose of it, because there are certain regulations around where they can put it once they take it out of your lagoon. So sludge measurement options. You've got sludge judging, Secchi disc, infrared sensor, and sonar depth finder, and I'll go through each of these in a minute. So the first one here is sludge judging, and you can you probably heard of these before. These sludge judges have been around. It's really a tube, a 2-inch diameter tube that's got measurements on 1-foot increments, and it has a little foot valve at the bottom, right? That as you shove it down in the water, it lets water through that foot valve and sludge, and some sludge through that foot valve, and then you can pull it up and you can kind of see how much sludge is in there. So this is a little video here of a sludge measurement being done by Steve Harris, a good friend of Triple Point. And you know, it's a pretty common and well-known thing. You can buy these things on USA Blue Book. The problem with sludge judges is they're not necessarily designed to measure lagoon sludge. So this is a little diagram here of the foot valve at the bottom. And basically you have this little ball, and as you push it down, the ball lifts up to the side, and then the sludge comes up and around the ball through those little gaps and into the tube. So this might work well for clarifiers in a mechanical plant, and this is really where the sludge judge was developed, because the sludge in clarifiers tends to be lighter, fluffier, it's not as condensed. In a lagoon, you often get sludge that's been sitting there for 10 years, and that tends to be thicker, denser. It's simply not going to fit around this little ball valve. It just doesn't fit around that little ball, right? And so you're cramming something into a fairly small opening, and if you're pulling that up and looking at it and saying, oh, that goes to the 2-foot marker, I've only got 2 feet. That's not really going to be an accurate measurement of sludge, because you compressed a lot of that sludge and not all of it's gone through that foot valve. So I do caution against using these, but I still think they're good. What they're really ideal for is they're really ideal for total depth measurement, right? So how deep is my lagoon from the bottom to the top? And not all lagoons are flat, by the way. So every time you do a measurement for sludge, you want to figure out what the total depth is at that point. The second thing they're really good for is pulling that all important core sample. They will allow you to get a decent enough profile of that core of the sludge in order to send it to a lab and get the testing done that you need to get done. So where the sludge judge fails, the Secchi disc steps in. So Secchi discs are typically, they were really designed to measure turbidity in water, but we've kind of adapted their use. And it's this little disc, it's super cheap to buy, it's got a rope on it, and if you drop it in the water, you can let it sink all the way to the bottom, and it will sit on top of that sludge blanket. And so it can really, really give you a good sense of what the depth, right, of the water is above the sludge blanket. So pretty simple. You get the Secchi disc on the rope, you mark in 6-inch increments all the way from the bottom to the top, every 6 inches. And then, once you drop that disc down to the bottom, it'll sit on top of the sludge blanket. You'll feel a little slack, right? Then you're counting how many of those 6-inch increments you did from the bottom to where the top of the water is, right? And then you're writing that down. And simply the sludge depth is lagoon depth minus Secchi disc depth, so water depth above the sludge equals sludge depth. Very simple mathematics, very straightforward, very inexpensive, great solution. So, that's what we typically recommend is the Secchi discs plus the sludge judge. Those are the only pieces of equipment you need to do a sludge survey, including obviously a boat. Alternative to the Secchi disc is you can use these cool infrared sensors. So these are, again, utilized in clarifiers. And really it's an infrared sensor that has a little weight on it. You drop it down to the bottom. It beeps when it hits the sludge, and then it will tell you how deep it is. And you can even record on a little controller all the different measurement points right there. So you don't have to worry about writing them down or doing anything like that. So it can be a kind of a faster way of collecting the data. I think these can be really accurate when calibrated correctly. So it could be a faster and easier way to collect the data on how deep your sludge is, or do the same thing a Secchi disc would do. They're around $1,500. I think we actually have one of these here that we use because it does allow us to collect the data a little bit faster because we just boom, 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 click it, hit it, right? So what's really, I'm seeing more and more that's like more popular these days is the sonar depth finder. And so this is a little boat that floats around in the lagoon, and it uses sonar technology to basically send signals down and see what bounces back at them. This one in particular, super cool. This is obviously a beautiful design. It actually can work entirely autonomously. So you set it up, punch some buttons on the screen there, put it in the water, it'll zoom around the lagoon, and it will produce a survey for you. So this is kind of what the output looks like. You've got, these different measuring points. It pulls it up, it gradients it for you, it analyzes the data for you. It'll take your garbage out and make your breakfast at the same time, kind of thing. So really cool technology. I would say first of all, it's expensive, right, to buy one. Now there are a lot of services out there that will do this for you, companies that do a sludge survey for you using sonar boat technology like this. So you don't necessarily have to buy it yourself. And so I'm seeing more and more of that where customers are like, oh yeah, they're going to do it for me, and they're going to use this sonar boat to do it. The other thing I think that I get concerned about with these, and this is not, I don't have any data or any evidence to prove my concerns, but I take a step back and I say to myself, first of all, it's not going to take a core sample for you. So unfortunately, you still need a sludge judge. You still got to get out on a boat and pull that core sample, right? Secondly, calibration is really key. And the thing is, like, sludge is not a monolith, right? There isn't one thing that's sludge. It's really, as you get towards the bottom, yes, there's your heavier, denser solids, as you can see from this picture here on the right. You see the dark black stuff. That's clearly sludge. But then there's gradients of sludge as you go up in the water column. So where is it pointing? Like, what is it detecting? Is it detecting just the dense stuff? Or is it detecting some of the gradients? And when does it become solid versus when is sludge still liquid? And what is it detecting in that respect? And so I think calibration is really key with this. And I think especially if you're going from into an industrial lagoon where you've got different types of solids, like if you don't calibrate it correctly, you don't validate the data correctly, you could be getting data from this that's just simply not right. So my kind of keys to proper sludge measurement. First of all, I think you can't be afraid to get your hands dirty, right? Like, we all have this beautiful image of being able to sit on the beach on the side and let the automated sonar boat flow around the lagoon, and we can sit there and chill out and watch it do its thing, come back in, go back into the office, right? Unfortunately, I just don't think it's as simple as that. I wish it was, but it isn't. And maybe one day they'll really hone in the sonar technology where this thing is lights out, will work, and it will collect a core sample for you. Maybe. But you need to get those multiple measurement points. You need to get those core samples. And if you're out there on a boat anyway, like I would get your DO probe out and do a DO profile of your entire lagoon, right? Take at every point you measure sludge, put that DO probe in, go 2 feet down, 4 feet down, 6 feet down, 8 feet down, measure all of your DOs at those points, and then come back and look at your overall data to see where DO is in the lagoon or where it's less in the lagoon, or if you're even getting enough in there, right? Because it can be an indication of how much sludge you've got. So I just think it's really important that unfortunately, you really just got to get out there and get the job done. And you can use sonar boat technology. I think certainly it can save you time, but ultimately, at some point, you're probably going to need to get in a boat and do something. So you get all this data, now you need to analyze it, right? So this is that lagoon profile from that I showed you previously, or with all those measuring points across the lagoon. We took them all, we put them all on this table here, and we're kind of measuring them. And we can plot these from Lagoon 1 to Lagoon 2, Lagoon 3. So what you can see here is, obviously, Lagoon 1 has the most sludge in it. Makes total sense. In certain spots, they have 3 feet of sludge or so. Lagoon 2 seems to have a little less sludge than Lagoon 3 does, which is sort of surprising in a way. But when you consider that this lagoon system was actually aerated, it kind of makes sense, because you keep some solids suspended, you break down solids in Lagoon 2, and then whatever is flowing into Lagoon 3 is a quiescent lagoon, and those solids tend to settle, and they settle down in that final polishing lagoon, which essentially acts as a clarifier for the whole system. So it's, again, super good data to have, right? Now you know where you're at in each lagoon, you know how much sludge you've got. In this case, we recommended they remove sludge. They had a little bit too much sludge, certainly in cell 1, and it was causing issues with their treatment, and they could see that in their numbers. And so we recommended that, but while you're at it, you might as well do Lagoons 2 and 3 as well, for the aforementioned reasons. Then you can take the data, compare it year to year to year. So once you start to compare it year to year to year, or 6 months, or however often you do it, you can start to see how the sludge is building up and how fast that sludge is building up over time. In this case, this is not a year-to-year comparison. This is a, across a 12-month period comparison. And actually, in this case, we actually installed our aeration system, and we saw that they reduced sludge over a certain period of time because the aeration really helped to mix up the volatile solids component on the bottom and help to break down some of those volatile solids components. So this is kind of the opposite of what you would see if you didn't change anything, but gives you the same kind of impression. So in this case, we actually reduced sludge from December 2017 to November 2018. I think in this case about 30% or 30 or 40%. So it's pretty huge, which was awesome. And we'll talk more about sludge removal next week and the different aspects of sludge removal next week. So once you've got all these readings, you know what your depth is, you want to start calculating your volume, and you want to get your volume in cubic feet. So pretty simple volume calculation. You're taking your sludge depth by your square feet that you measured, and you're getting your cubic feet of volume. Pretty simple math, right? Length times width times height. Now you can do this if you set up a grid and you've got all the different grid spots across the way. You can do this for each grid portion. You can understand what the volume of sludge is in each grid portion, get all that, add it all together, and there's your total number. Or you can just take the average sludge depth in the lagoon, just for quick and dirty math, and times it by the square feet of bottom area in that lagoon to figure out how much sludge you've got in it. Once you get your volatile solid back from the lab, you get your volatile solids test. They typically will give you total solids, and they'll give you volatile solids. So really, this is just a matter of calculating what the percentage of the total was the volatile. So in this case, it's 16,900 milligrams per liter of volatile solids, 35,000 milligrams per liter of total solids. That's 48% is volatile versus non-volatile. So what you tend to see is that with older sludge, you have a higher non-volatile percentage. With younger sludge, you get a higher volatile percentage. And this is important, and this will become important, and I explain this next week, because if you're going to look at removing sludge, it really behooves you to look at ways in which you can reduce the amount of volatile portion of that sludge. That is super, super important, right? Because if you can break that down in the lagoon, you don't have to remove it, you don't have to take it out, you don't have to pay a contractor to take it out. That could save you lots of money. And so typically what we would do in this scenario is we do this calculation, we come out with this sort of pie chart analysis. You could do a stacked bar if you want to compare year to year, and just really kind of get a good sense of your volatile versus non-volatile. And then if you do go in on a project to do in situ sludge removal, right, which I'll talk about next week, plug for next week's webinar, you'll see over time how you can reduce the volatile solid component, which is awesome. So sludge accumulation rates. This is a series, just kind of a catalog of studies on sludge accumulation rates that were done over the years, different papers. Honestly, everybody's sludge accumulation rates are different. It really depends on your lagoon age, on your hydraulic loading, your lagoon geometry, your climate, the amount of aeration, oxygen mixing you've got in there, the metals that you've got in there, the solids, the grit, all that stuff that comes into your lagoon. So it's hard to generalize, but these could be some good guidelines to, like, if you did a sludge measurement this year and you wanted to sort of project forward, right, into future years, it can give you a sense, right? It can give you a general sense of how fast you can expect sludge to accumulate. And then once you get that general sense, you can produce a really cool graph like this, right? Where it's basically looking at, well, in this case, they took a number of different of these studies and said, okay, well, if this study was right, how much sludge would accumulate over the next 20 years, right? Or actually, this is 40 years, 45 years. And if this study was right, it'd be this. And if our sludge accumulates at this rate over this amount of time, how does that also impact our hydraulic retention time? How does it reduce our hydraulic retention time? And you can start to learn, like, hey, well, at some point, the sludge accumulation intersects with the hydraulic retention time, and we know we're going to not have enough hydraulic retention time because we've got too much sludge, right? So this graph is way overcomplicated, way over engineered, really cool though. So I'll take it. But it just shows you what you can do with the data if you start to measure year to year, and if you start to project forward, so that you could potentially know 20 years from now when you need to remove sludge, and then you can start to budget, right, that sludge removal now, which is what you should be doing instead of waking up in 20 years and be like, oh crap, we got to do sludge removal, right? You can start to set aside funds for that, or you can start to look for grant funds for that, or whatever the case may be, or start talking to an engineer about that. This is a really critical part of lagoon management, of lagoon wastewater management. And the better you can predict what's coming down the line, what you need to do down the line, the better off you're going to be, and the better position you're going to be at to make sure your lagoon is always performing at the level it should be performing at. So, takeaways. So biosolids are just an inevitable part of any wastewater treatment process, right? And if you don't manage them and prepare to manage them within a lagoon, they are really the Achilles heel of lagoon systems, right? Like, they will hurt you over time. So really important that you pay attention to it, that you understand it, you understand how to measure it, you understand how to project forward and plan and so on to remove those biosolids and manage them. Some solids are organic versus non-organic. You really want to understand the difference between the two. Excess sludge leads to odor, benthol feedback, pH, algae, reduced treatment, and low DO, all problems you do not want to have. And by the time you're having them, or the time you have them in a very acute fashion, it's too late. And now you're doing a fire drill trying to figure out how to get sludge out of your lagoon when you don't have the time or money because you didn't plan for it, right? Measuring sludge is a vital tool. That's how you guard against those issues. You got to understand how much sludge is in your lagoon, right? Good sludge surveys are all about multiple measurement points, tracking across time, taking core samples, understanding that volatile versus non-volatile component of your sludge. And then I just recommend using multiple different methods for measuring sludge. I think the Sedgy disc and the sludge judge are by far the cheapest, easiest way to do it. Sonar boat can be also awesome. You know, if you calibrate it this year, maybe you can calibrate a little less next year, and so on. Give you a little bit more of a detailed view, but just make sure you calibrate it. But you know, use these things that are at your disposal to test your sludge levels, because you're gonna need all the help you can get to make sure you get accurate data. With that, I thank you for coming, and if there's any questions, we got about 10 minutes for questions here. Put them in the chat. Any questions, put them in the chat. Eve is gonna come on here and shoot some questions at me when they come out.
Hey, Patrick, I'm ready to shoot some questions at you.
Okay.
When you're sludge judging, you're going to pull core samples not out of every point, but out of, so you said 6 to 12. Does it matter which places you pull the core samples from? Like, does the constituents of the sludge tend to be the same across, or do you want to do edge pieces, center pieces?
So, you know, obviously you want to do the core samples by lagoon. So if you have more than one lagoon, take one core sample for lagoon 1, or one set of composite core samples for 1, 1 for 2, 1 for 3, right? I don't think it matters a whole lot where you pull the core sample. I think you want to kind of get an even look at it. So if you had 5 rows in your test, you know, in your survey plot, pull 1 core sample from each 5 rows, right? And whether on the edge or in the middle, just try to get a representative sample. It's not going to be perfect, right? We're not going to pull core samples from each spot and test that. We're just trying to get a general sense, and the sludge doesn't tend to change from location to location within the same lagoon, right? It's more better that you get a general average than to be spot on.
Do you have a ballpark estimate for the cost per cubic yard to dredge?
Good question. I don't have one offhand. I probably do somewhere, so we'll have to get back on that question.
What's the most sludge you've ever seen in a lagoon system?
Well, that study of the sludge reduction, I mean, they had a 15-foot deep lagoon with about 10 feet of sludge in some areas. And that was an industrial lagoon. So that it's not uncommon to see that. But yeah, it was bad. It was really bad. They just hadn't managed any biosolids at all, really, ever. And so, yeah, that's pretty bad. Municipal, I'd say, you know, again, anything over 2 feet is starting to get concerning. You just don't know when that's going to come up and bite you in the butt. I would say, you know, I've definitely seen some lagoons with 5 feet of sludge in them, and usually it's a bit of a cluster at that point. It's not a good situation to be in.
Is there a better time of year to do a sludge judge? Is it better to do it in the summer?
It doesn't matter. It's not going to be affected by temperature a whole lot. I'd say summer or winter. Spring, I mean, if you're having a turnover event, maybe that's not the best time to do it, but even then I think it's probably fine.
How long does a turnover event tend to last?
About a month, typically. It does vary by the amount of solids that you have. So if you have more volatile solids, more sludge, you're going to have a maybe longer time period. But typically it's about a month, I think, that you kind of go end to end with it, and with the acute period maybe being 1 to 2 weeks. But it's hard to generalize.
Can you give a brief example of a sludge judging experience of the setup, how long it took to go through and actually do the sludge judge?
Yeah, obviously it depends on kind of how big your lagoon is and how many sampling points that you've got. But you know, you're starting out by you know, marking off and staking off the rows and the different rows and lengths that you're going to do it, right? And typically you want to have you have a boat and you tie off on both sides a rope, and you can do it. You can do it with just 2 people, 1 person on the boat, 1 person on the shore, but it could be helpful to have 3. So you have 2 people on either side of the shore holding the rope, plus 1 person on the boat. And so you're just getting out to approximately each location, sampling point. Doesn't have to be perfect. It's approximate. And you're, putting the sludge judge down. That's, maybe 30 seconds. Taking a total depth measurement at that point. So you're marking that off. Then you're pulling it up. And if you want to take a core sample at that point, you're then taking that sludge judge, putting the end of it in a bucket, pushing up on the foot valve to allow the water to get out at that stage and dump into the bucket. And then you're doing your Secchi disc at that point, which again, maybe another 30 seconds. So I think a lot of lagoons, like for a single lagoon, it's maybe 1 to 2 hours, depending on the size. If you're doing a big lagoon, it might take you half a day to get those different sampling measurement points that you want. So, I mean, I think depending on how many lagoons you got, it might take a couple days max to get all the measurements you want. But I think most lagoons are probably in that half day to 1 day range.
We have time for more questions. I don't have anything lined up.
Okay. Well, I think we'll wrap. Well, unless anybody's got any more questions, last call for questions. Okay, well, thanks for coming. Like I said, next week we're going to talk about sludge removal. And so I will definitely have the answer to your question as to the cost per cubic foot of sludge removed, or typical cost to expect. That can be a bit of a moving target, I think. But definitely have that answer to the question and give you a general sense of what these things cost and how to go about it. So if you're interested in learning more about biosolids management, definitely invite you to join us next week. And thanks for coming today, and I really appreciated giving this and preparing for it. It was a lot of fun.